In this video, we're going to look at graphically solving a system of linear equations. Okay, so recall that y is equal to mx plus b. This is the slope, and this is the y-intercept. The solution is going to be an ordered pair, or it's going to be infinitely many solutions, or it's going to be no solutions. Okay, if it's an ordered pair, that means we have two different lines that cross at one place. If it's a infinitely many solutions, that means the two lines are the exact same, so they're set on top of one another like this. So everywhere on the line is a solution. And if there is no solution, that means the lines are parallel, so they run right next to each other, but they never actually cross each other. Okay, so let's take a look at the first one. What we want to do is get both the top and the bottom equations set equal to y. Okay, so I'm going to, this one's already set equal to y. I'm going to look at that 6x minus 2y equals negative 2. Bring it down there, 6x minus 2y equals negative 2. I'll subtract the 6 from both sides. And that gives me negative 2y is equal to negative 2 minus 6x. And then I divide everything by negative 2 to get y is equal to, let's see, that will be positive 3x. And negative 2 divided by negative 2 is 1. Okay, so we've set it equal to y. I'm going to go ahead and write it back up here. So we've got y is equal to 3x plus 1. Okay, so notice that these two lines are the same. When I cleaned up the first one and set it equal to y, it turned out to be the same. So this is going to be the same line, which means we're going to have infinitely many solutions that follow this. Okay, so let's go ahead and graph it. So plus 1 is my y-intercept, and then my slope is 3. So it's 3 over 1, up 3, over 1, or you can go down 3 and left 1. And this is both lines. Let's see, 1, 2, 3. Okay, so that should be enough. Okay, so that is both lines. That's what that graph would look like. Okay, and we can just say it has infinitely many solutions since both of these graphs are going to be the same line. Okay, so that is one possibility. If you want to get it where you can plug in a solution, or if you want to get it written in a different way when it's infinitely many solutions, you can write it this way as a point. You've got x, comma, and then 3x plus 1. Okay, because that's what y is equal to always. If you have x, then y is always going to be equal to 3x plus 1. Okay, but either way, this is infinite solutions. Same line. Okay, let's take a look at the next one. We got one of them that is solved for y already. We've got another one that's not. Okay, so let me take that second one, x plus 2y equals 3. Let's move the x over, so that's 2y equals negative x plus 3, and divide the 2. So y is equal to negative 1/2 x plus 3 over 2. Okay, so let's go write that back up here above that first one, which is y is equal to negative 1/2 x plus 3 over 2. Okay, so that's our second line. Get rid of that one now. Okay, so notice that they're not the same line, so we don't have infinitely many solutions. Another thing that we can tell from this is since the slope is different, they're not going to be parallel lines. Okay, so we know that if we're going to have just the one solution on this. Okay, so let's graph both of these. We'll graph this one first. So I go up to 3 halves, which is right here, and I have a slope of negative 1 over 2. So down 1, left, or let's see, we'll go down 1 and then right 2. So down 1, right 2, 1, 2. We can also do that again. So down 1, right 2 again, be here, or up 1, left 2 would be here. So that's what that line looks like. And let me graph that. Okay, so there's that line. Okay, and now for the other one, we cross at 3. I'm going to put this one in green. So we cross at 3, and we have a -2 slope. That's -2 over 1. So that would be down 2 over 1 would be right there. And that looks like that's probably our point. Down 2 over 1, down 2 over 1, or up 2, left 1, be this. So our second line looks like this. Okay, and this right here is our intersection point, right? And it looks like it's 1, 1. Okay, and you can confirm this. And our solution is 1, comma 1, but we want to make sure. So let's pop it into these originals. Okay, so I have the function y is equal to -2x plus 3. Let's plug a 1 in there. So 1 is equal to -2 times 1 plus 3. That's 1 is equal to 1. That's true. Let's look at the other one. The original one was x plus 2y equals 3. So 1 plus 2 times 1 equals 3, and that one is also true. Okay, so this works. The solution is 1, comma 1. All right, let's look at our last problem here. We've got x minus 3y equals -3, and then y is equal to 1/3 x plus 2. Okay, so second one is already solved for y. Let's get the first one solved for y. So x minus 3y equals -3. I'm going to subtract the x from both sides. So -3y equals -x minus 3. And then I can divide by -3. Okay, and that gives me y is equal to, that's, y is equal to, this cancels out, okay? And then the negative by the negative cancels out. It's going to be 1/3 x, and then plus 1. Okay, so that's our second one. Let's go write it up here. Y is equal to 1/3 x plus 1. Okay, so that was this one. Notice that they have the same slope, right? But they have different y-intercepts. So this means these two lines are going to be parallel. Okay, they have the same slope, but one of them crosses at 1 and has a 1/3. So up 1, 3 over is the slope, up 1, 3 over. Down 1, 3 left. Okay, so it's going to look like this. Okay, and then the other one, in green here, crosses at 2. That's the first equation here, and has a slope of 1/3. So up 1, 3 over, up 1, 3 over, down 1, 3 left, down 1, 3 left. Okay, so this line will look like this. And as you can see, those two lines are parallel. They will never cross each other because they have the same slope with different y-intercepts. So this problem has no solution.